Have you noticed we're always throwing things off buildings? Anyway, the time t in seconds, so t is time again, it takes for a free-falling object to fall h feet is given by that formula. T equals the square root of h over 16. Use this formula to determine how long it would take an object to reach the ground if it is dropped from a building which is 384 feet tall. So the height, or h, is 384 feet. Give the exact answer and the approximate answer rounded to the nearest tenth. Okay, we're going to take care of this for you, but before we do, there's something, that's a division problem or a fraction inside that radical. So we have to kind of talk about that first. So let's take a look at this this other information about that. We've already talked about this guy before. The square root of 16 times 9 equals the square root of 16 times the square root of 9. We just did that in the last lesson. What I want you to understand about that is that means we can multiply anything that's inside a radical as long as the indices match. So if your indices match, all I have to do is multiply the radicands, the stuff inside. Okay? Same thing with division. With division, if I have 100 over 4, that's the same thing as saying the square root of 100 over the square root of 4. Some people rather see it this way. Some people rather see it this way. But again, it doesn't matter what we have inside our radicand. We can reduce it or divide it, and I like to say reduce, as long as our indices match. So that's what you have to be aware of when we do these problems. So let's take a look at how to simplify a radical, because we talked a lot about before how to deal with this stuff, 25x squared. We were having a little fun with that. I don't know if you were, but at least somebody was, okay? And that this is just 5x, because 5x times 5x is 25x squared. But what if we have something like, that's on your slide, the square root of 20. The problem with the square root of 20 is that it is not a perfect square. So what I want to try to do is I want to try to simplify it. Now that doesn't mean I want to tell you what whole numbers it's between. I can do that if I want. I could say the square root of 20 is between the square root of 16 and the square root of 25, which makes it between 4 and 5. That's not what I'm trying to do here. What I'm trying to do is simplify it. And the reason is I want a more exact answer. The exact answer means that I don't want to give you that decimal that goes on. I don't want to approximate it. I want to keep it under the radical, but I want to simplify it if I can. Simplifying means to take out all the perfect squares that are underneath that radical. So let me show you how to do this. It's really very, very simple. If you're going to simplify radicals, the first thing you're going to do is check if it's a perfect square. Because if it's a perfect square, you're just going to square root it. Done. Okay? But if it's not a perfect square, what you're going to do is you're going to break it up. And I like to do this. Some teachers do this a little different. But I like to make two separate radicals. And I like to put all the perfect square factors in the first one. So I have to be familiar with my perfect squares. I don't really want to need 1 because I'm not going to use 1. 2 times 2 is 4 because 1 is in everything. 3 times 3 is 9. 4 times 4 is 16. 25, 36, 49, and I'm going to keep going if I have to later. So I want the biggest number that divides into this without a remainder, and that is 4. The biggest number off this list. So this first number, if we're talking only numbers, the number has to come off your perfect square list. Then you say to yourself, remember this is attached by multiplication. Then you say to yourself, what times 4 gives me 20? And that, of course, is 5. So now I have the square root of 4, which is 2. Take it out of the house because it's perfect. Think of this as kids. When kids are perfect, they're allowed out of their house. Okay? This is the house. These are kids. This is the house. When kids are perfect, they come out of the house. When kids are not perfect, then they have to stay in the house. Or if the cages, if you want to think of cages, same thing. Cages, houses, same thing. So we have 2 times the square root of 5. You don't need to write the little dot for times. We know it's there, just like 2x. That says 2 times the square root of 5 is the square root of 20. I can prove that. How can I prove that for you? Well, to prove it, I have to have done what I just did. I had to learn how to multiply because I have to say that this times itself should be this. So I'm going to check it for you right now so you can see that it really is true. Okay, check. 2 times the square root of 5 times 2 times the square root of 5. Okay, these are the coefficients, the 2's. These are the radicals. Okay, I multiply outsides with outsides. So 2 times 2 is 4. Square root of 5 times square root of 5 is the square root of 25. But this is 4 times the square root of 25, which is 5, which is 20, and that's what I had up there. So I did check. It looks good. And the reason I know this is simplified is because, look, there's no perfect square factor. Remember, these are factors because they're attached by multiplication. There's no perfect square factor in 5. 4 doesn't go into 5 without a remainder. 4 times nothing is 5. 9 is too big. So I know I'm done. That's one of the ways I know I'm done. So that's how you simplify radicals. So now let's take a look at when we are absolutely sure a radical is reduced. So let me read these for you, or simplified. The radicand contains no perfect square factors other than 1. So the only perfect square that goes into this 5 is 1. Nothing else. No other perfect square. So that's correct. All exponents under the radical, well, we don't have any, but all exponents under the radical, for instance, if I had the square root of 5x, all the exponents have to be less than the index. So that 1 has to be less than a 2. All the exponents here have to be less than this, otherwise we have more to do under there. So that's another rule. The third rule is there are no fractions under the radical sign. And for now, and it really does depend on what we're doing. Sometimes in calculus it's a little different. But for now we don't, or for some reasons it's a little different depending on what we're doing. For now we don't want a radical in the denominator of a fraction. So we're going to make sure all those 4 things hold. Okay? So now it's time to revisit the challenge problem. Okay, this is the challenge problem. This is how long it takes for an object to reach the ground. Okay, so we know the height of the building where this free-falling object is coming from is 384 feet. So all we have to do is do this. T equals square root of 384 all over 16. We can either write these separately, square root of 384 over the square root of 16. It doesn't matter. Or we can keep them together. It doesn't matter how you write it. I kind of like it together because for me it's easy to tell that I'm just going to divide there. So I'm going to take this and I'm going to see if it works out nicely. 384 divided by 16 happens to be 24, so that works out nicely. Look at the directions. It says give the exact answer and the appropriate answer rounded, approximate answer rounded to the nearest tenth. Okay, now, this is the exact answer. However, we would never leave your answer like this because it breaks one of the rules of when a radical is simplified. There is a perfect square factor in 24. Let's take a look at our perfect squares. Okay, 4 divides into 24. Nothing bigger does. Okay, remember, it's got to go in without a remainder. It's got to be a factor. So 4 is the biggest perfect square factor of 24. So we're going to break this up. Square root of 4 times, yes, you got it, square root of 6. Square root of 4 is 2. It's perfect, comes out of the house. Square root of 6, not perfect, stays in the house. That's your exact answer, 2 times the square root of 6. I know you want to break 6 up. I always do too. But you can't, okay, because there's no perfect square factor in 6. If you're saying 2 times 3, that's not a good idea because neither one of those are perfect squares, so that does not help me. That's the exact answer, 2 times the square root of 6 feet. Oh, no, seconds. Sorry. Seconds, not feet. I apologize. It's time. It's time. Yes, it's time. Now, it also says to do it to the nearest tenth. Give us the approximate answer to the nearest tenth. For that, I'm going to have to use my trusty dusty calculator. Now, and it is dusty because it's old. Okay, so I know you say, well, you don't get a calculator. Well, I know that. But I just want you to see that there's times where you really do have to learn more information and learn how to do more things. I'm never going to ask you to do this by calculator, obviously, if you can't use a calculator. But I can. Okay, so let's do the square root of 24. Let's think about this for a minute. Square root of 24 is between 16, the square root of 16 and the square root of 25, but closer to 25. So I'm thinking that we know it's between 4 and 5. I'm thinking it's really close to 5, 4.9 or something. Okay, so here we go, nearest tenth. Now let's remember how to round, all right? We need to go to the thousandths place so that we can round to the tenths place. And we get 4.89, and it keeps going, going, going. Okay, so look what I said. I said about 4.9 rounded, and this is true. If I round this to the nearest tenth of a second, it's 4.9 seconds. And this little squiggly equal sign stands for approximately. Is that an I? I? Approximately. I. It's an I. Okay, so it's approximately 4.9 seconds. And that's done. And that's not even, see, that's the approximate answer because it's not exact because it keeps going and going and going. Because remember why it goes. That's not a perfect square, so it's irrational, okay? And that's the exact answer. So that's how you do that problem. So now we're going to do a few more and make sure you understand this process. All right, let's look at these. Square root of 200, we want to simplify. The first thing I want to do is see if it's a perfect square. Well, no, it's not. If we look at our handy-dandy perfect square list, 36, 7 times 7, 49, 8 times 8, 64, 9 times 9, 81, 10 times 10, 100, 11 times 11, 121, 12 times 12, 144, 144, 13 times 13, 169, 14 times 14, 196, 15 times 15, 225. So 200 is not on my list, okay? And the more you do, the better you'll get at seeing that this is definitely not a perfect square. Okay, now what I do is I go from the bottom up because I want the biggest perfect square that divides into 200 without a remainder, okay? So here we go. Well, obviously, that's too big. 196 times nothing. 169 times nothing gives me 200. 144. But 100 does. 100 does. Okay, so let's 100 times 2. The square root of 100 is 10. Comes out of the house because it's perfect. Square root of 2 stays in the house. So it's 10 times the square root of 2. I am done. Now, I'm going to just tell you something. A lot of people like to do this. Here's the problem with that. First problem with that is this isn't even a perfect square. We want the first one to be a perfect square, but you're going, well, this is a perfect square. Oh, yeah, it is, but it's not the biggest perfect square. You could do this, but watch what would happen now if you did this. You would get the square root of 50, and this would be 2. So you'd have, I'm just going to do it here, and then I'm going to erase it anyway, 2 times the square root of 50. But now you've broken a rule. The rule is you cannot have any perfect square factors here, and you do. Watch. So all attached by multiplication. 50. Well, 81's too big. 64. 49 times nothing. 36 times nothing. 25. 25 times 2. Well, this is 2 times square root of 25 is 5 times the square root of 2. 2 times 5, they're both outside numbers now. That's 10 square root of 2. Look, we got the same answer I did, only you went through Japan. Okay? So it's a lot easier if you come up with the biggest perfect square, if you can. That's why I make a list. Okay? It makes it a lot easier. All right? Okay, let's look at this one. We're going to erase this. Square root of 48. So it's helpful to know the perfect squares, and it's helpful to know your multiplication table. Okay, negative square 48 is not a perfect square. It's very close to the square root of 49, means it's very close to 7, but who cares? We're not asking that. All right, so 48. 49 times nothing, 36 times nothing, 25 times nothing, 16, yes, 16 times 3 is 48. Oh, I wish I paid attention when I was learning my multiplication table. 16 times 3. Okay, this is just bring the negative down. Square root of 16, it's perfect. Take it out of the house. Square root of 3. And you are done. That's it. Okay, ready? 16. 16 is an outside number. 27 is not a perfect square. It's close to 25, but not a perfect square. So it breaks up into 2. Okay, the biggest perfect square in 27. 25 times nothing is 27. 16 times nothing is 27. 9. 9. 9 times 3. 9 times 3. Okay, awesome. So now we go 16 times the square root of 9. 9 is a perfect square. It comes out of the house. 3 is not a perfect square. It stays in the house. 16 times 3 is 48. Square root of 3. Okay, 48 square root of 3, and you are done. 48 times the square root of 3. Okay, ready? For the cube root, you actually need perfect cubes. So we have to make a list of perfect cubes. I have to tell you, I'll show you in a minute what I usually do to make a list of my perfect squares, cubes, and fourths, and all that stuff. I don't think that we go much further than cube roots, so I would just make them for square roots and cube roots. Okay, here we go. Cubes. One we don't need. 2 times 2 times 2 is 8. Remember, part of our rule is it can't be 1. 3 times 3 times 3 is 27. 4 times 4 is 16 times 4 is 64. That's pretty much as high as I'm going to go. Okay, whether you know or not, 27 does go into 81. Okay, so cube root of 27, 27 times 3. Well, the cube root of 27 is 3. Oh, a lot of 3's going on. 3 times the cube root of 3. I can prove that. You go, no, please don't, please. But I can prove that. Watch. Here's what this means, remember. Haven't done it with a cube root yet. It means if I multiply this by itself 3 times. Oh, I'm going to do this down here. It's okay. I'll get back there. 3 times 3 times 3, 27. Times the cube root of, inside, 3 times 3 times 3, 27. This is 27 times the cube root of 27 is 3. 27 times 3 is 81. Awesome. Got it. See, it works. It works. Okay. I'm going to do the square root of x to the 9th. Now, I have to tell you, I do this totally different than probably anybody else you've ever seen. Okay, you ready? Here's what I do. I look at the index, and I take multiples of the index. First of all, I look to see if, I look to see if it's perfect. It's not perfect. How do I know it's not perfect? Because it's not divisible by 2. It's not even. As soon as I see it's not perfect, I break it up into 2, just like we've been doing with all of these. I break it up into 2. I haven't kept saying that. I should have. I apologize. Okay, here's what I do. I take multiples of 2. 2, 4, 6, 8, 10. I take the closest one without going over. The closest multiple of 2 without going over to 9. The closest one is 8. That gives me x to the 8th. Well, x to the 8th times what is x to the 9th? X to the 8th times x to the 1st. Right? That gives me x to the 9th. The square root of x to the 8th is keep the base, divide the exponent by the index, x to the 4th, square root of x. And you are done. That is your answer. Okay, I could prove that by squaring it. Okay, I will. Check. Check. X to the 4th times x to the 4th is x to the 8th, square root of x squared. X to the 8th, square root of x squared is x, which gives me x to the 9th. So I proved it. And I have to tell you, here's what most people do, because some people said, hey, you're doing a video, but I want you to show my way. I'm going to show them your way, their way. Okay, this is their way. Pick your own poison. Okay. They do something like this. Well, x to the 9th. I know I need an even number of them, so they pair them off. If that was a 3, they'd pair them off by 2s. I think they actually do this in their head because I can't really think that they'd be doing this. All it is, what if that was x to the 98th? Okay, but they pair 2 off. If this was a cube root, they'd pair 3 off. But they go, okay, 1. How many groups of 2 do we have? Okay, so we have 1, 2, 3, 4. We have 4 groups of 2. Okay, so that's x to the 4th, and there's 1 left, square root of x. Okay. If that makes you happy, fine. That makes me happy. What makes me happy is doing the multiples, 2, 4, 6, 8, 10, picking the closest one without going over, because now we know it's even, okay? And then your leftovers here, and you're done. And there's your check. Pick your own poison, okay? There's a couple more in your book. Oh, no, actually, I have a couple more to do, and then we have some for you. All right, let's try a couple more. All right, this is the cube root. The first thing you want to do is see if they're all perfect. Well, x to the 12th is perfect because it's divisible by 3. But y to the 5th is not, because it's not divisible by 3. Okay, and we know we're not done simplifying. Well, first of all, because we have a perfect square. Second of all, because this is not less than this. Okay, both of these have to be less than that, and they aren't. So I'm going to take multiples of the index 3. Okay, remember that's how we're going to deal with the exponents. So I'm going to go 3, 6, 9, 12. Okay, and that's as far as I have to go because I can't go over, remember. So now I'm going to break it up into 2 because it's not perfect. Don't forget to write the little 3 for cube root, otherwise it's square root. X to the 12th is perfect. Do not mess with them. Do not fix what's not broken. Only split them up when they are not perfect. x to the 12th is perfect. Do not simplify it first. Do not divide. That goes at the very end when you've done this step, okay? Don't do some part of that step here and part at the end. You're going to get it wrong. Okay, y to the 5th. We want to get as close as we can to this without going over, okay? So the first one without going over is y cubed. 6 is too big. So this is going to be y cubed, but y cubed times y to what power gives you y to the 5th? Y cubed times y to the 2nd gives you y to the 5th, okay? So now we're going to cube root it. Now to cube root it, this is all perfect. It comes out of the house. The kids are perfect. They get to go out, okay? Actually, I think it's when the kids are bad, they should go out so they can leave me alone. But I'm not really sure. But anyway, okay. Kids are perfect, you go out. So x, keep the base. 12 divided by 3 is 4. Keep the base. 3 divided by 3 is 1. And this just comes down for the ride. Okay? And that's it. And that's how to solve that problem. Simplify that problem. We're not solving anything. Simplify that problem. Okay? Let's do number 3. Okay, we got to look at the number first. And remember, the reason we can do all of these is because they're factors. We're going to look at the number first. 54 is not a perfect cube. X squared is not a perfect cube. Y to the 4th is not, nobody's a perfect cube. By the way, forgot to say this. I know I'm done here because the exponent is less than the index. Okay? All right, so let's take a look here. We're going to break it up into 2. We're going to deal with the number first. Okay, the number first, you have to take the number off this. Numbers off this, off your list, okay? Exponents off the multiples of the index, okay? Different. All right, so 27 goes into 54. I'm going to take the negative with me. Negative 27 times 2. 27 times 2 is 54. Okay, now x squared. Now remember what we're doing for the exponents. We're taking multiples of 3. So we got 3, 6, 9, hike. Okay, well, we got to take the closest one without going over. The problem is they're all over already because x squared is simplified. So that goes here to the simplified side. Because look, this is less than this, so I can't break that up. Now we go y to the 4th. The closest one to y to the 4th without going over is y cubed. So we have y cubed times y. That'll make it y to the 4th. You know you're headed in the right direction if 2 things are going on. This times this gives me this, which it does. Okay? And also everything here is a perfect whatever. Here it's cube, and it is. And everything here is not a perfect cube, which it's not. Okay? And does not, and also can no longer be simplified. 2 can't be simplified. X squared can't be simplified. Y to the 1st can't be simplified. Okay, so now we're going to cube root it, and we get negative 3, because negative 3 times negative 3 times negative 3 is negative 27. Keep the base. 3 divided by 3 is 1. 2x squared y. And we are done. Awesome. Awesome. Okay. Number 8. Look to see if everything's a perfect square. This is not, this is. Okay, that's a perfect square. So really what we have here is square root of 32 all over y squared. Now, I'm not done unless there's no perfect square here. So now I need to make a list of my perfect square. I have perfect cubes here. So let's do that. Perfect squares are 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, and then 36. Okay, well, what's the biggest number that divides into 32 without a remainder? Without a remainder, it is 16. So I break this up to the square root of 16 times the square root of 2 all over y squared, which is 4 square root of 2 all over y squared. Now, I hope you're not thinking, well, the square root of y squared is y. You need a y here. No, this is not the square root of y squared. This is just y squared. We took the square root of y to the 4th. We got y squared. Once you take it out of the house isn't there. That's it. Don't keep square rooting until you can't go anymore. There's no more square root sign on it. So this is my final answer. This times itself will get me back to here. Okay, and that's always your check. Okay? Here, of course, you have to multiply this by itself 3 times, and that's just pure fun. Okay, let's take a look at this last one. Well, notice that x squared is already simplified because the 2 is less than a 3, and 8 is a perfect cube. 2 times 2 times 2. So the answer to this problem is quite simply the cube root of 8 squared all over 2. We are done. And that's it. That takes care of the rest of them. Now there are a couple for you to do. Try those, and we'll come back and we'll see if you're correct. Okay, let's see how you did. Square root of 50. Not a perfect square. That's the first thing you look for. So we're going to break it up into 2. That's how you know you're going to break it up. Okay, you might want to put that little dot there to mean multiplication so you know you need factors. Now go to your list of perfect squares. Okay, I would start at the bottom. We need 50. 64 is too big. 49 times nothing. 36 times nothing. 25 times 2 is 50. Okay, square root of 25 is 5. 5 times the square root of 2. Awesome. Okay, let's do negative the square root of 24. Well, the negative comes down, and now we break this up into 2. Okay, and now 24. 25 is too big. 16 times nothing. 9 times nothing. 4. 4 is the winner. 4 and 6. So this is negative 2 square root of 6, and you are done. 6 cannot be broken up. Okay? Don't put 12 in here. 12 is not a perfect square. Okay? Even though 12 is a factor. Okay? We're trying to look for the biggest perfect square to put in there. 4 times the square root of 75. You got to look at 75. 75 is not a perfect square, so you got to break it up into 2. Okay, here we go. 75. 81's too big. 65 times nothing. 49 times nothing. Nope. 30. 25 is the winner again. 25. This time 25 times 3. Remember, this is all attached by multiplication. This is 4 times 5 times the square root of 3. Now these are both outside numbers. We have 20 square root of 3. Awesome. Nope, no negative. I thought I lost my negative. Okay, now we're going cube roots. Let me get a new pen. That looks like it's dying. Okay, cube roots. I don't think I need square roots anymore. Cube roots. Stay away from 1 because 1 goes into everything. 2 times 2 times 2 is 8. 3 times 3 times 3, 27. 4 times 4 times 4, 64. That's enough. I'm done. Okay, 24 is not a perfect square. Cube. So I break it up into 2. Don't forget the little 3's on top for cube root. 27's too big. 8. Yes, 8 works. 8 times 3. So this is, the cube root of 8 is 2, because 2 times 2 times 2 is 8. Cube root of 3. Okay? And now this is cube root of x to the 10th. Remember what we do with exponents? Yes, we do the multiples of the index. So here we go. We have 3, 6, 9, 12. 12 is too big. Okay, remember that's not a perfect cube because it's not divisible by 3, so we need to break it up into 2. It's x to the 9th, cube root, times x. X to the 9th times x to the 1st is x to the 10th. Now we take out the perfect square, and the square root of x to the 9th is x to the 3rd. Remember how to do that. Divide the exponent by the index, and this just comes along for the ride. So it's x cubed times, because there's times that you don't see, cube root of x. Hope you did pretty good on those. I think I actually like the exponents better than I like the numbers, because I have to really think about the numbers. Okay? So we're going to do 6 through 9, and then we're going to call it a lesson. All right, let's see how you did. Exponent's my favorite. Here we go, square root. So we're going to take multiples of the index. The index is 2. 2, 4, 6, 8. Why am I doing this anyway? Okay, I'm doing this because this is not a perfect square, this whole product. Y to 4th is a perfect square, but z cubed is not because of that 3. I went a little too far, but that's okay. Here we go. Break it up. Y to 4th is perfect. Leave it alone. Z cubed, the closest exponent to 3 without going over, that would be z squared. Z squared times z. The square root of y to the 4th is y squared. Square root of z squared is z. Square root of z. So we are done. Okay? Awesome. Cube root of 8. Cube root of 8. 8 is a perfect cube. 1 is not. And you can't even simplify it because it's too small. It's smaller than 3. 11. 11 is not a perfect cube because it's not a multiple of 3. So I need to break this up. Okay, look at that. I didn't give that second guy half enough room. Okay. All right, 8's a perfect cube. Don't break him up. We said x cannot be broken up because it's too small. Think about the multiples of 3. 3, 6, 9, 12. Okay, 1, you can't get anything you pick will go over that because 1 cannot be broken up because it's smaller than that. So that's got to go in the second one. Y to the 11th. Y to the 11th, the closest one without going over is y to the 9th times y squared. Add the exponents, you'll get y to the 11th. Remember, I could multiply that through, and I should get back here. The cube root of 8 is 2. The cube root of y to the 9th is y cubed because you divide the exponent by the index. And then this guy just comes along for the ride because it cannot be taken out of the house. So there you go. Awesome. Ready for this? The top is not a perfect square, but the bottom is. Okay, so since the bottom is, I want to take care of it. I want to get out all the perfect squares I can. So here we go. Oh, except the square root of 4 is 2, not 4. Okay, so that's a 2. All right, now let's look at the top. So we're breaking up the square root of 10x to the 50th. Well, let's look at our perfect squares again. 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. 10 is not a perfect square, and 10 doesn't even have a perfect square factor. None of these numbers, 10 isn't divisible by any one of these numbers. So here's how that's going to break up. Now I'm doing, just so you know what I'm doing, x to the 50th. Here we go. 10 cannot be broken up. 10 cannot be broken up, so where should it be? Come on, keep me honest. It should be here. Cannot be broken up. X to the 50th is divisible by 2, that 50, so it is a perfect square. So that is x to the 25th, right? Because we divided by 2, square root of 10. So that's the top. So my final answer is, are you ready? I'm going to have to take this off. My final answer is, this is x to the 25th, square root of 10, all over, goodbye, goodbye, bye-bye, all over 2. And we are done. Hey, pat yourself on the back if you got that. Okay, last one. In this last one, this square, it's not a perfect, this is x squared, it's not a perfect cube. In fact, it cannot even be simplified because 2 is smaller than 3. This is a perfect cube. So your final answer, very simple, is the cube root of x squared all over 2. Because 2 times 2 times 2 is 8, and you are done.